Consider the statement, "The singing in the intro to this video was enjoyable." True or false? You might be a little troubled by this question. How can you tell if singing was good if it wasn't singing? In this class, we've been discussing logic that is bivalent, or where there are only two truth values, true and false. This is a simple and great solution for many statements. The earth is round, true. Mr. Barnes teaches English, false. But there are some circumstances where bivalent logic breaks down. Take this statement, for example. Mr. Barnes stopped beating his wife. The problem with this, as well as the statement I mentioned in the beginning of the video, is that they make prior assumptions that can't be changed by whether the sentence as a whole is true or false. So bivalent logic, where we enforce that sentences must be either true or false, falls apart in these situations. So if bivalent logic doesn't work here, how are we supposed to evaluate these types of statements? Well, in 1952, an American logician by the name of S.C. Kleene devised a three-valued logic system called K3. In his system, a sentence can have any of three truth values, true, false, or indeterminate. In Kleene's system, the statement, "Has Mr. Barnes stopped beating his wife?" would be indeterminate since we can't know or can't define whether it is true or false. You can use all the things that are in bivalent logic in K3 logic as well, as long as you are only dealing with values of true and false. Here are some truth tables in K3 logic. First of all, negations. The negation of an indeterminate is also indeterminate. For example, Mr. Barnes has stopped beating his wife is clearly indeterminate, and Mr. Barnes has not stopped beating his wife is also indeterminate. For a conjunction to be true, both of the involved sentences have to be true. So if one is indeterminate and the other true, the conjunction is also indeterminate. But if one of the values is false, then no matter what, the conjunction is false. For disjunction, as long as one of the values is true, the disjunction as a whole is true. And if one is false and the other indeterminate, the disjunction as a whole is indeterminate. With this, we can see that A or not A is not always true, because A could be indeterminate. In fact, tautologies do not even exist in K3. This makes it a bit difficult to do natural deduction. Using conditionals, we can also see that if A then A is not always true. Natural deduction can be done in K3 even though there are no tautologies. Other than this small issue, natural deduction still works the same. The K3 system cannot be used to evaluate all statements. For example, take the Sorites paradox. A grain of sand is not a heap. Adding a grain of sand to something that isn't a heap does not make a heap. Therefore, there are no heaps of sand. Using bivalent logic, this holds true. And using K3 logic, it is concluded that it is indeterminate whether heaps of sand exist. However, we know that heaps of sand do exist. An American logician by the name of Lofty-Zadeh came up with a new system called fuzzy logic. Using fuzzy logic, you can set the definition of a heap. Fuzzy logic uses a truth value from 0 to 1, with 0 being completely false and 1 being completely true. However, the values that are set using fuzzy logic are very arbitrary and completely change from person to person. So although fuzzy logic can be used to evaluate more statements, its practicality is limited.
3 weeks later, many months later.
So much later that the old narrator got tired of waiting and they had to hire a new.
An indeterminate in the K3 system is generally defined as a 0.5 in the fuzzy system, and we can use math to determine exact truth values of anything. A negation, for example, is 1 minus a. So a negation of an indeterminate is also indeterminate, just like in K3. And if a is false, or 0, then the negation of a, 1 minus 0, is 1, making the negation of a true. These are the basics of fuzzy logic, but as you can see, it can get quite complicated. So, as you have probably realized by now, our traditional bivalent logic system, while amazing for working with simple statements, doesn't cover everything we need. Even besides the two systems we discussed today, there are plenty of other logic systems that are meant for uncountable different types of statements and situations. Hopefully you've learned a little more today about how to treat sentences for which one can't know if they are true or false, and those that seem to fall just in between.